informations are independent of each other, and the user's identity information is controlled by an organization which may not only reveal the user's identity information due to the single point of failure. The main problem of the existing authentication techniques are single point of failure. So, overcome the problem, I introduced an identity authentication system which is based on a hybrid blockchain for intellectual property, which is denoted as IP. A hybrid blockchain. A hybrid blockchain is combination of public blockchain and private blockchain. I use hybrid blockchain because of it provide more data security compared to the public blockchain and private blockchain. Intellectual property rights refer to the legal rights given to the inventor and creator to protect his invention or creation for a certain period of time. Intellectual property can consist of many types of asset, trademarks, a patent, and copyrights. So, in this figure, there are different type of intellectual property like confidential information, design, patent, trademarks, copyright, etc. In this existing work part, I service is several papers and find out some disadvantages and advantages. In the first paper, they are proposed an identity model and reputation model. Advantages: node can't change any data and effective resistance from various attacks. Disadvantages: it is not so effective on conducting big scale data. In this second paper, they proposed an identity hierarchical model and self-sovereign identity model. These advantages: easier procedure for data verification and it is cost effective. Disadvantages: data protection is less effective. Uh, in this third survey paper, they proposed a conceptual design and high-level architecture for a personal data and identity management system. Advantages: higher data integrity and stored data can't be modified. Disadvantages: transferring saved data from service provider of to off chain data store is ineffective. In this third survey paper, fourth survey paper, they proposed a blockchain based identity management system. Advantage: protect the integrity of data by using a private blockchain to effectively preserve information access and authorization requests from user IDs. Disadvantages: the privacy of the transaction is protected by cryptographic measure, so it is still danger of data leaking while it is stored. In this fifth survey paper, they proposed a privacy protection identity authentication scheme on blockchain. Advantages: effectively reduce storage overhead problem and no single point of failure. Disadvantages: less the data security because of their use public blockchain. Uh, in this part, I will discuss my proposed authentication technique. My proposed authentication technique classified into three phases: initialization, registration, and authentication. In the initialization phase, this phase is divided into two parts. First one is intellectual property authority, which is denoted as IPA. And second one is blockchain network. And third, this is my system model. Um, uh, in this system model, there are three entities: the data user and owner. Second one is IPA, means intellectual property authority, and blockchain network. In initialization phase, user and owner generate his or her public key and private key using elliptic curve cryptography algorithm. And end of this phase, user send his identity, public key, and real identity to the authority. So this is the first algorithm, elliptic curve cryptography encryption algorithm. I use this algorithm for generating public key and private key. Second phase is registration phase. In this registration phase, IPA first verify the user identity. If user identity has already registered on the blockchain, then IPA reject the registration request. Otherwise, IPA generate his public key and real identity of the user, which is encrypted by authorities public key, and it also generate a signature for the user. And then the signature generation completed by using a chameleon hash algo. Then IPA sent encrypted private public key of IPA and real identity of user and signature to the user. So this is the second algorithm which I used for signature generation and signature verification. In authentication phase, in this phase, user first generate a timestamp, then uh, user send identity users send his identity, signature, and timestamp to the authority. Uh, then IPA check timestamp and verify the signature of the user using chameleon signature verification algorithm. If timestamp does not belongs to the range of the current time, then IPA reject IP access request. Otherwise, IPS IPS search public key users public key on the blockchain. If IPA find user public key, then IPA verify user signature with user's public key. After signature verification is done, then the user access all IP application services. Conclusion and future work. In this semester, I investigate getting and analyzes several paper, and I introduced a proposed authentication strategy, which is identity authentication system, which is based on hybrid blockchain for intellectual property. And my future work is I implement my system model practically using Ethereum blockchain. These all are my references. Thank you, sir.
Now, sir, if you have queries, sir, please ask.
Yeah, thank you, Daisy, for your presentation. How many
Welcome, sir.
papers you have studied till now? How many papers you
Uh,
have studied till now?
Sir, in authentication, I studies minimum uh, 15, and then I study hybrid blockchain, and in the second semester I studies basic of the blockchain. So, sir,
Okay,
in my project or authentication, I studies more than 15.
good, good. And the problem already you have got it. That is the gap in their papers. What are the
Yes, sir.
problems lies with them, and you are trying to get that authentication using hybrid blockchain,
Blockchain. Yes, sir.
right? So
Yes, sir.
So, in this manner, what is your best paper? That is based on which paper you are thinking that this paper helps me a lot. You have studied 15 in reference, you have
Yeah.
given some 8 or 10.
Yes, sir.
So, which paper is the best paper for your work?
Sir, sir, this paper is my base mm, paper.
This paper is
Privacy.
the best paper. Fine.
Yes.
Go and sing. And when this paper was published?
Sir, 2020.
2020.
Yes, sir.
Okay, fine.
Did
And
you given it
your
in
work,
the reference?
yeah, reference 5 he sees showing. So reference 4. Then next?
Reference 5.
No. Yes, this
Oh,
reference 5.
Five.
Gao Seng.
Yes, sir.
This is 2021. Good. So it is recent
Yes,
paper
sir.
and you are
Oh,
working on it.
20.
That, yeah,
Yes.
identity authentication scheme based on the blockchain. Fine. So here, considering this paper and when you are giving in reference, try to give the all the examiners, sorry, all the authors' names, not the et al.
Okay,
In
sir.
reference, you should give all them. You should refer all them, not one or two. Fine.
Okay, sir.
Yeah. Thank you. Thank you. Good. Carry on.
Okay, sir.
Carry on.
Welcome, sir.
okay. Next you, Jonto, you start. Yeah, Jonto, you start. Switch on your video.
Sir, sorry, sir.
Switch on your video.
Sir, first of all, sir, I would like to thank you to giving me the opportunity to introduce myself before your panel. Sir, myself, Joyanto Das, and today I am going to discuss about my investigation on privacy preserving thin client in blockchain for ITS.
Make it full screen.
Sir, this is my outline. We will start from the introduction to and
Put the title
in
page. Put the title page.
in
Title page. Title page. First, first,
and with
first,
future work,
first,
sir.
first,
You
first,
return to the last slide, previous slide.
first slide.
This one,
Yeah,
sir.
yeah. You start from here. Yeah.
Okay.
Ah.
Sir, first of all, sir, thank you for giving me the opportunity to introduce myself before your panel. Sir, myself, Jayanto Das. Today, I'm going to explain my investigation on privacy preserving thin client in blockchain for ITS. Sir, this is my outline. We will start from introduction, then we will go to existing work, then proposed technique, and then future work. Sir, this is introduction. What is privacy preserving? Sir, here in the figure, we can see that A is sending some data to B. And there is a person C that wants to know that what type of data or what B is getting. Sir, not allowing C to know what type of data A is sending or B is getting is privacy preserving in respect to A and B. Uh, Sir, then comes sir intelligent transportation system. Sir, it is a application of sensing, analyze, control, and communication technologies to ground transportation in order to improve the safety, mobility, and efficiency. Sir, in the figure two, we can see that a blue car is finding a parking slot. Sir, here in intelligent transportation system, we use many different technologies to get different types of intelligent systems like car parking, etc. Sir, these are the few of my existing works. Sir, Ian Lee et al. Introduced a efficiency and privacy and enhanced federated learning. And this advantage is, sir, it can stop privacy leakage from both the shared parameters and local guardian. Sir, this disadvantage is not proven for higher dimensional data sets and complex neural networks. Sir, in the second author introduced an enrollment framework, and its main advantage is that it will improve the efficiency of the safety and of ITS. And sir, the main disadvantage is the blockchain technology is ITS requires more resources, manageability, and time consumption more than the traditional systems. And sir, the last author introduced the PTS scheme, that is the privacy preserving thin client scheme. Advantage is it is more secure and good computational power, and its disadvantage is it is prone to attacks. Sir, before coming to the proposed technique, I would like you to know that, sir, in my while my investigation, I have found that, sir, traditional car parkings are vulnerable to attacks, and they do not pay attention to the user's privacy. And sir, and another thing, sir, I have found that the PTS is a good privacy preserving technique. So, sir, I decided to make a car parking that preserve the privacy of the user in blockchain. Basically, it is a car parking system. This consists of registration of the vehicle and the verification of vehicle. That means that how the car will have its own parking slot. Sir, before coming to the models, sir, I would like to know, I would like you to know that my system consists of three things, that is, sir, PPA, that is a permanent parking authority, and PA, that is a parking authority, and a vehicle. First, sir, this is the registration of vehicle. How a vehicle will register to PPA? That means the permanent parking authority, which is a blockchain, and which is a full client, and it has its own blockchain. Suppose, sir, if a car comes with PPA with its identity and ask him to register first. Then the PPA will ask a government database to send the credential information regarding this car, that is the idea, regarding the idea. After, sir, here we consider that we all have the permission to send the request to the government side and have all the access to the credential information of the cards. Sir, after getting all the information about the vehicle, the PPA with the help of the smart contract will decide that whether the car provided, the information car provided is matched with the government database or not. If this is matched, then it will store the it will store the record of this car to this blockchain, and this is how the car will register. Car will register, sir. Sir, after that, the verification of the vehicle, sir, that means how the car will allot its parking spot. Suppose, sir, we assume that this car is already registered with PPA 1 or 2 ppm, any one of them. Sir, this is the PA, that means the parking authority. Suppose, sir, this car comes nearby a PA and wants স্যার ওয়াইফাইটা গেছে, সরি স্যার। হ্যাঁ আছে আছে তো, সরি স্যার। স্যার, আই ওয়াজ ইন, hello sir.
Now getting. Yeah.
Sir, this is the verification of big. Suppose, sir, in, sir, we assume that the BK.
Connect to wired network. Why you are going for wireless Wi-Fi?
Sir, the laptop doesn't have port.
Eh? What laptop you are using?
নাই তো কি তো।
Yeah, now start.
Sir, this is the verification of
Full screen.
Sir, suppose, sir, this car is already registered with one of the PPA, that means the permanent parking authority. Sir, there is m number of PPAs, and this is the PA, that is the parking authority. Suppose this car comes nearby the parking authority and wants a parking slot to the PA, then the car first send its IDA, that is the identity and the public key, to the PA. After that, PA will select K number on K minus 1 IDs, such as, sir, this IDG, IDH, and IDA, along with this IDA, and send it to the m number of PPAs. After that, in third number phase, the full node user, that is the PA, PPA will find its own blockchain to the recent transaction posted by this IDA, IDG, and IDI, and find the corresponding public keys and send back to the PPA. In phone number step, the PPA only pay attention to the received PKAs from the m number of PPA. It only focuses on the PPA. There is three conditions: if all the returned PKA is same, and if returned PKA does not belongs to the PKA that the vehicle provided, PA can confirm that the PKA does not belongs to this IDA. And there is another condition: if all the returned PKA is not same, and PA can confirm any dishonest node among the m number of users. Suppose, sir, all the PKAs is not the same, all the PKAs is not same, then PA will confirm that there may be any dishonest nodes among these PPAs, and it will reselect the nodes again. In third number step, if all the return pk equal to the pk that the vehicle provided, that pa can conclude that the pka equal to this ida, and pa will send a message including his id, that is idb, and a nonce to encrypted with the public key of the vehicle, and send it to b means the vehicle. In fifth number step, the vehicle will decrypt with a secret key for getting this message IDB and NB. Suppose if B is a full node user, it will search for own blockchain to get corresponding PKB to IDB. Then B will send a message that uh, including his nonce and the nonce of the PA and the IDA, and encrypted by the public key of PA to PA, and send it to the parking authority. In six number step, PA decrypts the received message with its secret key and SKB to obtain NA and checks if NB in the message or not. If NB is in the message, PA will PA can confirm that B is the owner of that IDA, and PA sends NA and the nonce that is encrypted with PK to the beacon. After that the beacon will decrypt the received message with its secret key SKA, and checks the presence of the nonce, that is nonce NA. If it is in the message, PA is the owner of the IDB. PA is the owner of the IDB, and this is how my whole authentication process will success, and this vehicle will allotted a car parking slot in PA. Sir, this is the future work, sir. Sir, in this semester, sir, I investigated several techniques, and sir, and made this proposed system. In the next same semester, sir, I will implement this system, and the more important that I will analyze the performance of this system, sir. Sir, these are the references that I took, and sir, thank you, sir. Sir, this is all.
Sir, if you have any queries, sir, please ask.
Yes. So, yeah, Juanto, thank you. So,
Yes, sir.
how you are implementing this? In which language or which platform you are doing?
Sir, right now, sir, I am not, sir, implementing it till now, sir. I will be implementing, sir. I am thinking to go with, sir, Ethereum, Ethereum, sir, it's for blockchain development, sir, blockchain purpose. And sir, rest of the, sir, thing that I have to think, sir. In this semester, I will think and implement.
So, implementing through Ethereum, whether you have started anything? No.
Sir, I just started some basics that I just read in the articles, not yet started, sir. In this semester, I will start.
Okay. Okay, carry on, because implementation is the best one. Blockchain theory and proposition will be easier. Now you have to establish your work.
Okay,
Thank
sir.
you. Thank you. Carry
Thank
on.
you.
Next, Shiv Prasad, you can start your presentation.
Yes, sir. Sir, am I audible?
Yes, audible, but voice is distorting. Can you move away from this background, because from backside some light is coming, a sharp light is coming.
Yes. Yes, sir.
Okay, now fine. That's fine.
Yes.
Share your presentation. Share your screen. Yeah, yeah.
Sir, result. Good morning, sir. First of all, I would like to thank Mr. Dr. Abhishek Majumdar for his guidance, and last but not the least, Mr. Shukanta Chakraborty for his guidance too. Sir, this is my project regarding the blockchain sharding. And I'm going to my aim is to improve the scalability and throughput of the blockchain in any kind of blockchain by using sharding. So, sir, these are the outlines that I'm going to discuss now. The research objectives, the related works, and the system model, and the theoretical analysis and other things. Now, the main objective of my research is to discover the role of sharding in the blockchain system to increase the scalability of blockchain using sharding
See, you
to
have to
improve the
keep one thing in mind. Your presentation should be within 10 minutes, okay? So 10 minutes is the
yes,
time.
sure.
You cannot say for
Yes. To increase the scalability of blockchain using sharding, to improve the transaction throughput, to suggest new efficient consensus, and to study the cross-shard transactions. So, in any kind of blockchain, there will be three things which are needed, which are the blockchain cannot be done with the three things. These are security, scalability, and decentralization. These three are togetherly called as trilemma of blockchain. We all know about the blockchain. It is a shard. It is sorry. It is a distributed ledger. So what is sharding? Let me first of all discuss about sharding. Sharding is a process of dividing a big chunk of data into smaller pieces. Here, here is a diagram of data with sharding. The main block is divided into different shards. In existing work, Ethereum 2.0 will be going to divide each block into 64 shards. Okay. The main benefit of sharding is the higher transaction rate. So in now in case of Ethereum, there are only 15 transactions can happen in a second. So uh, only 15 transactions can happen in 1 second. So there will be there will be very less. It will be very less efficient. The bit there will be a waiting system for a people to register their transaction in the ledger. They need to pay some fees. In a study, it is discussed that sorry in a last study it is found that the transaction fees can go up to $50 per transaction. That is very much more. That is very much more, sir. So and it is not logical to give $50 fees for any kind of transactions. So we are using harding to maximize the throughput and scalability of the blockchain. These are the things that comes with sharding: layer one scaling, layer two scaling, proof of stake, consensus, centralization, exchange. These are some secondary benefits which are the node doesn't need to store the entire ledger to the whole blockchain. The node can store locally is also the information of the related shards. So so this is the layer sharding scheme. So this is the layer sharding scheme. Um, the layer sharding scheme the layer sharding consensus may commit cross-shard transaction in one round or in multiple rounds. Opposite to complete sharding, it requires to split each cross-shard transaction into many sub-transactions. It requires several consensus rounds to commit. Um, in the in the sharding scheme, there will be mainly three types of sharding, which is not three types of sharding. There can be complete sharding and layered sharding also. Layered sharding is a whole new approach, which is discussed in the paper called pyramid. So I am implementing my model in layered sharding. So in the complete sharding, there is in non-sharding figure, there is no sharding as you can see in the figure. In complete sharding, there are shard A and shard B. The nodes are divided between the shards. Then these shards can communicate with each other. If the shard A and B communicate with each other, that it will be called cross shard transaction. And if the nodes of any shard communicates with between the shard only, that is called inter-shard transaction. And in layered sharding, it can use both the shards by reducing the minimum number of cross shard transaction. So it can create high throughput. Okay, sir. This is my system model which I am going to implement. Before proceeding, these are two types of shards that I am going to include in my system. It is shard A, I shard A, and B shard C, and I shard B. The I shards are the inter-shard consensus, which are inter-shard consensus, which are the which what I meant by inter-shard is like the node will communicate between them only, between the shards only. And B shard C is called the cross shard conjunction, which is responsible for communicating with I shard A and I shard B. Each and every shard will consist this structure of cross shard block for any kind of shard, for its related shard, which will be consist with header and a body part. The header part will consist of parent hash, parent Merkle root, and body consists of the transaction, which what kind of transaction, and which is the state. Now, this is the design. First, it is called randomness generation, which will be generated randomly for picking up a leader. Then then comes the participation. The participate for participating in a epoch. Here epoch means a time period. I have in the previous study, the epoch was fixed time of period, but I have made it dynamic. So in each epoch, the participant needs to participate. Before participation, they go through a proof of work consensus, which will be very less efficient and very higher energy consuming, and less throughput will going to come. So I have modified it. So modified it in proof of stake consensus. Then there comes the assignment part. Here in the assignment part, shards are assignment random. The nodes are assigned randomly to any kind of shards based on the identity of the shards. Here in the now it comes cross shard block design. Transaction definition. In the transaction definitions, we need to define the sender and receiver. There can be more than one sender and more than one receivers also. The transaction, how the transaction is going to happen, we need to define it um, on a smart contract. Okay. The validation rule. Here comes the validation rule. Here validation rule consists of two parts, which is source validity and source validity and receiver validity. Here, what I mean is, suppose I am sending someone 100 rupees. So the blockchain needs to confirm that I already have 100 rupees to transfer. I cannot. It cannot be like that. I have only 100 rupees, or I am transferring 1,000 rupees to another person. The blockchain needs to validate the source validity, which that I am having 100 rupees, and the result validity that I am if I send someone some money, then he cannot tell that he didn't receive. The result validity should also be there. There comes the block design. Here in the block design, there are two types of shard that I have already mentioned earlier. Two types of shard is going to be the I shard and inter shards and cross shards. By these, I am going to design the block. Here, the layered sharding consensus. It is the layered sharding consensus. Before proceeding to this, it is basically three steps consisting of three steps: pre-prepare, block prepare, and commit. Here, in the figure, in the B shard C is the cross shard in the blockchain, and I shard A and I shard B is the inter shards in the blockchain. Here, a leader selected in B shard randomly generates a transaction, either randomly or it can be any kind of request also. It generates a transaction. Suppose A needs to send some money to B, or any kind of data to B. So first of all, B shards, the cross shard is only this. The B shard is only responsible for communicating shard A and shard B. Otherwise, shard A and B cannot communicate. So B first of all, raises a request to A and B that A wants to send some data to B by a collective signature. All of the nodes collectively signatures that collectively validates that A wants to send some data on B by cross-search transaction. The collective signature consists of header and body and the collective signature. Then A accept the message and B also accepts the message, which in the prepare phase, and they also collectively validate the transaction that yes, A will send B some data and send it to the cross shard. Now cross shard
Steve,
receives
quickly wrap
data
up.
from yes sir, yes sir, yes sir, from both the shards A and B. So B shards then commit the message to A and B in the commit phase. Okay, these are the design refinements that I am going to implement in my model, which is generic case. I am implementing the model only for one sender, not only for one sender. Now till now the work has happened for the one sender and one receiver. In general case, there can be many senders and many receivers also. The so I am going to refine this and parallel commitment, there is an issue. Then I'm going to also work on the storage optimization and the relation management. The storage optimization refers to the whole information of box. The dynamic number of nodes that can be assigned in a shards, which I'm going to refine afterwards creating the model. Okay, the limitations of the current study. The participation of before any the participation of in an epoch before anything, the nodes needs to go a proof of work first, which is very less efficient and very much energy consuming. So I'm going to and whenever previous epochs identities exceeds n, it's time the difficulty will raise, otherwise it will be decreased. Okay, the direction of future to suggest a new power saving consensus for layer side and dynamic system model, lower overhead, the proposed new structure in the or cross shard blocks, and accordingly reverse layer sharding consensus that can scale well number of related shards for cross shards blocks. So these are the reference that I have included in my project. There are many reference. I haven't included all of them. So that's it. Thank you, sir. So if you have any queries,
Thank you, Shiv Prasad, for your presentation. Yeah. So you are telling about CERD. Now, is there any
yes, sir.
difference in between the structure component in C programming, C language, and your CERD? How you can correlate these two,
Sir,
or is there any difference?
Sir, actually, shard is nothing but data. It is similar to database sharding. In the blockchain, the block is a huge, a huge block consists of different types of many types of transaction, which will like in the in case of Ethereum, it can only process 15 transaction. So Ethereum doesn't use sharding as of right. More than 1600 transactions like these. So, sir, am I audible? Hello, sir.
Yes, yes. Tell me. Yeah,
Hello.
tell.
But voice is distracted.
Hello.
Your voice is
Sir.
continuous.
Okay.
This distortion is there in the voice.
Sorry, sir. I don't know how it came like this. sir, can
Okay,
I
you
tell
tell. There is
the?
no way because you cannot go through the communication. Yeah.
Okay, sir. So by using charts, it will create a parallel transaction. Suppose a block is divided into six sub blocks, which I'm referring as charts. So there can be six transactions happening in this 1 second only. So a block in
No,
one
no,
second.
fine.
Suppose a block in.
Shiva Prasad, fine. Uh, yeah. No, you know
Yes,
C
sir.
language. In
Yes,
C
yes, sir.
language, structure component is there where we can
Yes, sir.
put on whatever we want. Your third structure
Yes,
is like that struct in C. Whether any dissimilarity or anything else you are getting, this is a structure component only, and structure can be used as per your own thinking in any security, in any blockchain, in any communication. We can think of a structure. So is there
sir. It is.
any other specialty other than structure?
Yes, sir. It is. As I think it is completely different than sealing, which was because the sharding protocol itself, it is not introduced in right now. It is only introduced in night scale, which is not in Ethereum. It is another blockchain, and it might be so different. It is as I have presented in my presentation. There are two types of scaling, which is layer one scaling and layer two scaling. Sir, you were telling the C structure is based on layer two. I can scale the blockchain using C by in layer two scaling only, and the concept of sharding itself in the core blockchain in layer one or layer zero scaling. So as of right now, no organization has implemented successfully sharding in their blockchains. It is only using the prototype, and it is not similar to the structure of C, sir. I cannot tell, sir, how the structure of the sharding comes out, because, sir, I'm going through this right now. But it is different to C structure, I think, sir.
Okay, okay. Thank you. You try to implement. Let's find out what you are getting there
Sir,
inside. Fine.
I have already tried, but the sir has suggested me to make a private blockchain on the Python by using the Python language. But still, I'm searching for a better option. Sir, let's see, sir, what can I do. Sir, thank you, sir.
Thank you. Thank you.
Yes, thank you.
Next, uh, Niladri, you start your presentation.
Okay, sir. Sir, I think my slides are visible.
It's visible. Make it full screen.
Okay. A very good afternoon, sir. Respected scholars and all my friends. So today I'm here to discuss about my research topic, that is two reternary recommendation engine with enhanced privacy. So these are my outlines. So I'll start with research objective, followed by introduction, problem with existing work, approaches to overcome, and so on. So what is my research objective? So basically, my main focus is as like all of the papers that are based on recommendation system I have gone through has mainly focuses on building strong recommendation model to achieve high recommendation quality. But such model directly stores user sensitive data to centrally located servers, which the user may contain some sensitive information also. But actually their aim is not to trace the data, but also to perform data collection for other purposes. So my aim is to design a tool recommendation system while keeping tourist data confidential. So in starting, we can go through what is tourism recommendation system. We all know the tourism recommend system provides suggestion to tourists to identify the most suited point of interest that tourists might to like to visit based on his or her interest. So as an example, we can consider, as I am from Tripura, Agartala, so there are some famous places, namely Jayanta Palace, Heritage Park, Tripureshwari Temple, and so on. So these are some of the POIs or point of interest that might be interested for someone or may not be interested for someone. So what are the problems with the existing ones? Almost all location-based service network social medias are using centralized traditional machine learning approaches, which not only taking the locations of the data along with many user-sensitive informations are also be traced, like age, geographical locations, relationship status, political views, genders, etc. So people are nowadays becoming very aware to data security as number of hackings has increased day by day. So if people are will not share data, so that will result in data sparsity. So for training any machine learning model, data is the main prime thing that is required. So my aim is to develop a unique way so that I can safeguard the user privacy also. At the same time, we should not reduce the efficiency of the recommendation system. Then I came about federated learning. This is an excellent innovation by Google. It was presented in late 2017 that instead of sending user data to the central server, an instance of the model is been sent to the each and every node. So I forgot to mention the working of federated learning is like that. We all use mobile devices. So these are the nodes that are participated in federated and learning in federated environment. These nodes train its own data by using its own data, and by one central model is present, the node present in the central server, which is sent to the local devices, and the device trains the model using the own data and and send the gradient to the central server. So in recommendation models, we will use matrix factorization, which is a very good collaborative filtering method while worldwide it's used. Basically, it is used to find the similar kind of users and to recommend things which may like by the user. So here are some of the literature surveys that I have mentioned in the presentation. The first paper that is presented by Lee Mitchell in 2017, where recommendation based on personalized travel packages with multiple point of interest, where preferred starting points and ending point is considered in this research. So if we mention some starting and ending point, there are a lot of POIs that we can cover. And the most motivated paper of my research is of our Joylal sir paper, which also included you. This is the first time they developed multiple itinerary recommendations. So users, if someone is visiting to a new place, can have multiple itineraries for that place. They can cover in a desired duration of time with price and interest constraints. But I have found that most of the researchers uses geotech photographs and central machine learning algorithms. But my question is that nowadays user is sensitive to share their information to the unauthorized servers or third-party aggregators. But uh, how can we how can we overcome this thing? So I think we can overcome if we use federated learning in recommendation, as it is widely used in many sectors where privacy is the prime issue. So there are also some papers regarding this. So there's a paper by Yetin Gyo et al. It was released in 2021. This is a very motivating paper for me. They have proposed a framework called Prefer, where they have they have divided the region into n number of clusters, named as S server, and each server is serving some region. So the users of that region is considered as a node, and they might interact with the server and get recommendation to other also they present in the area. Then this paper recently published by Huang et al. This is developed geographical peer recommendations of Internet of Things. This paper has really motivated me because this gives the way how I can actually use dedicated two written recommendations by using federated learning. They have uh, they have used what they have used the on they have used the ratings, and the only the POIs that the user visit will be shared to the central server, which be aggregated and on gradient on sorry only gradient will be shared to the main server, but the local data will be kept in the user device only, thus enhancing the privacy issues. So I would like to build a complete federated learning framework to recommend tourist POI recommendation for tourists. This will consist of n number of devices and a central server region-wise. Just like I have mentioned that in the Young Geo et al. Has preferred has built a framework called Prefer. So this way we can safeguard the sensitive information of the tourists to their device only, and only non-sensitive information will be shared with the in the form of gradient will be shared with the central server to train the main model. So how we can design the model? So POI recommendation is to predict the ratings of the similar user they might find interested in. So if you look at the blocks, so these are there might be some n number of POIs and n number of users in a particular region. We have to predict the scores of ratings. Based on this, we can provide the itinerary list for the tourist. So this is basically the framework of my proposed approach. So there will be n number of devices. These are called fat clients. There, an user might travel to different types of POIs in region, and their POIs will be updated in the local machine. Then gradient, and they might rated also those POIs. Then those POIs will be this gradient will be calculated from those POIs and ratings, and the gradient will be shared to a central server. And in the central server, there will be a global profile user and global POI user. So what will be in the location? Suppose an area has more than 30-40 POIs. If a number user travel three of them, and these three are unique, these three will be stored in the central server, three POIs. In second, and similarly, other devices, other people they also travel some of the places. Those POIs will be also noted in the global server, and we can explain with a real life example. It will be very much clear. Suppose the world is divided by countries, countries is divided by states, states is divided by areas. So suppose I consider my state Tripura. So Tripura has several districts. Consider that each district has set servers, and those servers support the region. I mean, this server covers the region, and this area has n number of users. Like I have mentioned, I have just for representation, pictorial representation purpose, I have used four of them. Those people might travel day-to-day activities, various POIs, and those POIs will be tracked, or those POIs will be tracked by the local server. And suppose a user one has traveled some places, user two has traveled some places. Might there may be some places user has not traveled, but user two has traveled. So what will happen from the central server? The all the accumulated POIs will be sent back to the local nodes to calculate the matrix rating, so which will decide that the next POI might be liked by the user that has been not traveled by the user. So what will be there in the central server? Central server will have two tables basically. One is POI table, as I have already mentioned that various users might have traveled different POIs, and those will be all accumulated in the central server. And another will be user profile table. User profile table basically is a fed aggregation, means we can decide a user what type of POIs the user like the most. In upcoming slides, it will be very clear. Suppose in Tripura Agartala district, consider a user one who might visited Ujjainta Palace. So Ujjainta Palace there is a lat long coordinates and along its categories. And another user two has visited Heritage Park same day. This is of another category. So these two data has been sent to the central server. So central server initially, the one drawbacks of federated learning is that initially the recommendation will be unable to do, because it will train gradually by iterations after iterations. So in fast iterations, they got the two unique places, and along with the ratings also, the gradient of ratings have been sent to the central server. So you can see that user one has rated the Ujjanta Palace 4, and user two has rated Heritage Park. These two are two different itineraries. Different POIs. So we will, in next iteration, as global server gets in a day two unique POIs, we'll send back those two POIs back to the user. Now as in this stage, the user might not get the recommendation as per his or his choice, because it's just initial iterations. In first couple of iterations, the efficiency will be not good. So if this process continue for several iterations, after that we can predict that what users might like what type of categories, and based on those categories and interest of those categories POIs, we can suggest those things. In upcoming slides, we see that in few more days, user one again travel some oxygen to parks. These two are of different parks, but previously the recommendation was based on the first approach, that he was travel a palace. So as there was no sufficient data, that the algorithm thought that he is the person who likes most the palace. But now the algorithm, after aggregating the weights, now will think that okay, based on his third attempt, total he has traveled three places. Out of three, two is the category of park. So the model can predict that the person might like park most than the palace. Similarly, things I have shown for the vice versa for the user two also. So this way, after several iterations, we can conclude as the model will age, after several iterations of training, we can conclude that these people has interest much more on palace than park or other categories. As for explanation purpose, I have used only two categories, but there must be n number of categories. Now,
Hiladri, wrap up quickly, okay?
sorry, sir.
Wrap up quickly.
Okay, sir.
Complete.
Uh, okay, sir. Now, how the n number of POIs will be calculated? See, we have used left long coordinate. So left long coordinate uniquely stamp the exact location of the area. So if the user has desired starting point, then we will calculate by using formulas. There is a formula available openly to calculate the distance between latitude and longitude. For as I have not implemented now, I have taken source from internet how to calculate the latitude longitude. Suppose if you start one itinerary has latitude longitude value of 23.856 and gradually and so on. So by calculating the distance of each POI that the user have to cover, we can find the distance, and based on nearest to end, we can arrange a itinerary list. And another thing is that suppose a user of one region has traveled to another region. So in user profile also, in central server of the user profile, there is a unique table that predicts the user interest. This will be transferred to the new place travel to the next place, next areas. So that based on similarity quotient, these areas might have of same interest people present in that particular area. So based on this calculation, the POIs that has been prevalent by the second user will be recommended to the first user. So this in upcoming days, I will try to implement using flower framework the federated learning approach of tourist recommendations. That will actually in upcoming days the data sparsity will increase. So I think this approach will reduce the data sparsity problem that actually nowadays facing by major companies. So these are some of the references that I used for just for presentation purpose. More references I have mentioned in my report for the entire study. Thank you, sir. Sir, if you have any questions, you can.
Sir, if you have questions, sir, please.
No, thank you. So how you are implementing?
I will use, there is a newly built framework called Flower, which is dedicatedly built to recommend for federated learning implementation. So for I will use this for simulation of federated environment. Actually, federated learning needs to be done in various device means various separated locations, but for simulation purpose we can use the Flower framework.
Good.
We
Good.
can
Carry
provide.
on. Yeah. Thank you.
Thank you, sir.
Yeah. Next, Obik.
Hello, sir.
Yeah, you are audible. Share the screen.
So, good afternoon, teachers and my dear friends. My name is Obik Pal. So, the topic I am working on is movie recommendation system by a dynamic
First thing,
tensor.
my name is wrong.
For
Okay.
myself.
So next.
So, what is recommendation system? So, it is also known as recommendation engine. It's a model for information filtering that aims to suggest or offer suggestion in accordance to the user preference. It is an important tool for online streaming platforms. So the goal of a recommendation system is to suggest movies that a user is likely to enjoy based on their previous preference. So the objective of the paper is to enhance the quality of movie recommendation system where user could find movies according to the preference and with high accuracy that could save their time. Next, we'll study their previous technique and their advantages. So to understand the third is that to understand the previous technique faults that have been worked on and to improve and provide a better recommendation system. Build a dynamic tensor recommendation system that has advantages of our previous techniques and has more advantages like better scalability, accuracy, and efficiency. So at last, we'll verify and do performance analysis of the system by verifying how well the model is meeting its goal or objectives such as efficiency, quality, customer service, satisfaction, etc. So this is the some related works that I have worked on. So first, Thekar that he introduced collaborative filtering technique. So it has few shortcomings like it relies on past user interactions to generate recommendation. So for new users who have never interacted to the system before, it will be challenging. Collecting and analyzing user data is a necessary component of collaborative filtering, which raises question about data privacy and security. Collaborative filtering relies on user data to generate recommendation, where when there is new user or new item in the system, there may not be enough data to generate accurate recommendation system. So another is item-based collaborative filtering. So the shortcomings is because it only takes into account that the products they have used have higher ratings rather than other attribute like preference. Because a movies may have, we can look to very different things to review a movie, but here they only takes only the ratings. So this is not acceptable. And item-based filtering tends to recommend popular items, often more than niche items. It can create bias towards certain types of items or limit their diversity of recommendation system. Another is hybrid approach. So hybrid approach, the disadvantages is it is complex because we have to work with too many algorithms. So hybrid filtering requires large amount of data and of the user because we have to manage many algorithms. So these are the shortcomings. So another is bias in personalized ratings. So it is the shortcomings is it requires large amount of data to train effectively and it can be challenging. So it relies on limited feature of item, which can limit its ability to generate accurate and diverse recommendation system. So a few problem statement is study of previous techniques such as collaborative filtering, content-based filtering, model filtering, and file their problems and disadvantages. The number of users or items in the given view, it became increasingly difficult to compute recommendations. So the recommendation algorithm face the problems of data sparsity, where large number of users or items had very few ratings or reviews, making it difficult or suitable to recommend. Suggest a new technique that can improve the previous technique shortcomings as well as provide better result and accuracy. So here in my, I have used dynamic tensor in my for recommending movies. So it is a machine learning technique used for personalized recommendation systems. Dynamic tensor is useful in the case because it can handle the variable number of users and movies and their ratings over time, allowing the system to adjust and adapt to changes in the data. It has the ability to handle temporal dynamics and other interactions. Example, a user preference for items may change over time, and the system can adapt to these changes by adapting the factor matrices as new data becomes available. So we'll be using cosine similarity. So with this, we can compare the similarity between two movies. Suppose it can check the if two movies have same actors or different same actors or same director or it is been shooting in same place. So cosine similarity does this and this works. So this is my proposed system. So here, first of all, we gather movie ratings data from various sources and pre-process it to make it suitable for recommendation system. Then the dynamic tensor will be created for movie rating. So we'll represent the movie rating data as a dynamic tensor. Like dynamic tensor is a matrix, type of matrix. So will be row as a user and column as a movie. So like this, it is defined. So filtering and cosine means is to compute pairwise similarities between the columns of the dynamic tensor. This has been used. This involves calculating the similarity score between every pair of movies in the tensor. Then after that, we'll use the similarity matrix score to identify similar movies based on the threshold or fixed number of neighbors. Suppose if I watch a movie, the next it will recommend like top 10 similar movies according to the movie you have watched. Then after that, after identification the similar movies into the information, then we'll generate for the movie recommendation system. Like this is a working principle. I have used dynamic tensor, and for data extraction, I'll be using implicit and explicit. Implicit data extraction, it means when the user logs into the system, so we'll collect information from the beginning. And explicit means when the user, after joining the system, when the user search according to his preference the movies, that on while surfing time will take the data from the users. And similarity matrix will be using then recommendation. It is just matrix factorization. Suppose M1 likes comedy movies and that's why he gave a rating 3 and action 1. He does not like. So at the end, we'll recommend something that is of higher rating. Then the comedy movie types of comedy movie will be recommended to her. So suppose in figure 3, we'll see that in the matrix means the first and the third, though they have given the similar ratings in the of the movies. So I will recommend what movie to watch for the third person. So since all the movie ratings are similar, so according to this, we'll give the same ratings. Suppose as one, he gave same rating 1 star to the movies. This is the process flow diagram. In step one, we'll gather information about the users and each movie, such as title, year, etc., and convert the data into a format that can be used by the recommendation system algorithm. And create a dynamic tensor with 3 dimensions, such as each dimension will take time, user, and movies in different. And train the dynamic tensor model on the normalized data and extract meaningful patterns from the data. Find similarities between users and movies. So after finding this, we'll suggest movies that will suggest similar movies according to this. So this is the flowchart of my work. So when the user logs into the system, first it will check is the user already registered or it is a new user. So after checking the database with the data from the user, it will be extracted. Then it will be filtered with movies like dynamic tensor and cosine, the user database. Then it will recommend a movie. Then recommend new movie stop. So suppose if the user is new, so and the priority does not match, so it will go back again, and according to his preference, the movie will be recommended. So the conclusion, dynamic tensor completion movie recommendation system is a promising method to increase the precision and relevance of movie recommendation. For dealing with missing data in recommendation system, dynamic tensor is used. So we have also shown the working principle of how it is working. So in future, we'll be working on the programming part as well as we'll build an algorithm so that it will help in step-by-step process. It will be easy for us. So we'll also compare with our previous models to find the advantages because it is in theoretically it is much advantageous than the previous works. So this is my reference. Thank you, sir.
Yeah, Opik, the first thing is that your presentations font should be bigger, otherwise it is not visible properly. Then another thing is that your progress should be faster. Okay, now, sir, if you have any questions, you can ask.
No, you are telling in future work that programming of the these things along with algorithm. So whether you have finalized the algorithm or you are telling here that proposed one, but whether that algorithm uh, in pen and paper in your mind, whether it is already established or you are searching for the algorithm or in the creation level.
So actually, sir means none of the paper that I have means seen in Tensor or they have given the algorithm. So means I know the process how it works, but so I did not means shown it here.
No, you
Means I
have
know the
shown.
steps. Means
Fine, you know the steps. Then programming, it should not take much more time. So your steps, whatever is there, in which language will you implement?
it will be in Python, sir. Totally in
in
Python.
in Python.
Yeah.
Ready-made packages are too much. Then within 7 days you can get the testing ones. So within 7 days you can have that programming, testing, and then debugging, and your efficiency enhancement will take some time, because always efficiency and debugging is a question. But framing those steps by step in Python, hardly it will take 2 to 3 days.
But sir, the programming part is not available. Means I have to create it because I'm new to machine learning.
Obviously,
Yeah.
obviously, who will give you the programming? You have to create your programming. You know the steps now, as you are telling. So, step one, you create first, attach it to step two, then step three, you add on in Python. Each line you can write and you can run it.
Yes, sir.
You
Means that is the work
will,
of my next semester. Yeah.
so, full
Means
semester
to
is not
implement.
required at all. It is required hardly total 1 month to complete everything if you are dedicated. Anyway,
Yes, sir. I'm
thank you.
working on it.
Thank you. Carry on. Carry
Yes,
on.
sir. Thank you,
Complete.
sir.
Yeah.
Thank you, sir.
Next, Sriya, you start your presentation.
Yes, sir. In the time, that's all.
My name is also wrong, and your mic is mute.
Yes, I am not getting you.
Sorry, sir.
Yeah,
Yeah,
please.
and in the slide, my name is wrong. Every day you see my name, then also you are making it wrong. Why?
Sorry, sir.
Okay.
Uh, Good afternoon, teachers, scholars, and my dear friends. I am Shreya Chakravarti, and today I am here to present my presentation on group recommendation system using sentiment analysis for user satisfaction. So these are the outlines, that is research objectives, introduction, literature survey, proposed technique, conclusion, and list of public. Hmm? Yes, sir. So these are the outlines. Research objective, introduction, literature survey, proposed technique, conclusion, and list of publication. Sir, the research objectives are, unlike previous approaches which only give
Again, go to the
recommendation.
previous slide. Go to the previous slide. List of publication means what? Your publication.
No, sir, the research papers.
What research papers? What are these known as? What are
So,
these known as?
sir, references.
So why you have given list of publications means your publication. Okay. Next.
Sir, unlike previous approaches which only give recommendation to a group of users by using aggregate functions, we have proposed a technique where a group of tourists can get recommendation by using sentiment analysis for better user satisfaction. Introduction. So basically, sir, web-based communities are digital areas on internet where tourists on group do involve with one another and share information. And a group recommendation system for tourism is meant to increase information sharing and raise the level of group members' satisfaction. Many group recommendation system has been proposed in the tourism domain, but using sentiment analysis can aid in improving comprehension of a user's attitude, views, and feelings. Here are the few literature survey that I have gone through. So this paper proposed a method that extract tourist preference based on their reviews and performs text mining and sentiment analysis. And also the shortcoming and the problem area of this paper is this approach does not include several factors including traffic circumstances, environmental factors like rain, flooding, or hot climate. The second paper stated that the goal is to focus on discovering underemphasized locations and top ranked locations to attract tourists. Underemphasized places are locations that are highly rated but have not received sufficient advertisement or coverage from tourism administrative and marketing parties. One of the shortcomings of this process is that the places with a smaller number of views or mentions by the travel blogger are less likely to be visited by others. This is the architecture of the underemphasized location recommendation. Here we can see the inputs are taken from the reviews, blogs, and ratings, and they are they are the text analysis module and the user history based data analysis, that is the age of the tourist or the history of the visit. They are processed into context where collaborative filtering and through cross mapping they generate a location profile, and they give a recommendation of the under emphasized locations and the top locations. This paper proposed Post via 360, a platform devoted to support the whole life cycle of the tourist loyalty after the first visit. The system is designed to collect data from the initial visit by means of pervasive approaches, that is during the post visit by the CRM approach. The shortcoming of this paper is, from the technical point of view, Post via 360 is dependent on a given dataset and to some extent on a given domain. The next paper proposes an improved group recommendation procedure that improves not only the group recommendation effectiveness but also the satisfaction of individual group members. The shortcoming of this approach is that this technique does not use the sentiment analysis. Now, what is sentiment analysis? Here we can see there is three comments by the user. The first one is positive, that is great service for an affordable price. The second is neutral, just booked 2 nights at this hotel, and the negative is horrible service. The room was dirty and unpleasant. So these are the sentiment analysis, means the emotions of an tourist after visit. This is the architecture of or the process how a sentiment analysis works. So first of all, a comment of a tourist or review is extracted, and there are 4 steps that are conducted. The first one is pre-processing, creating similarity graph, clustering, and extracting preference. So in pre-processing, there are 4 parts. First one is first of all, pre-processing is used to convert an initial document into a suitable processing. The first process is part of speech tagging. That means if a comment is taken or a sentence is taken, each of the words are labeled according to their part of speech. The second step is stop word elimination, that is all the unnecessary words are eliminated. The third step is extracting the nouns from the comment, and the last step is stemming means to uh, bring that sentence to its stem or base. For example, like cat like or cats are stemmed as only cat. The second step after the extracting noun is creating similarity. Each pair of noun are considered as the matrix entries. Then the second is matrix normalization is done in order to allow comprehension of data with different measurement. The third step is creating graph based on noun matrix. Then the similarity group is drawn based on this matrix. The graph vertex consists of nouns and its edges indicates the degree of semantic between between incident values. Now, then these nouns are then gone into clustering process where these remove the unnecessary edges. For example, if there are 2 clusters, cluster 1 is having A, B, C, and cluster 2 is having suppose D, F, G, then a sentence that contains A, B, D will be assigned to cluster 1 and both cluster 2. But a sentence that is having like GFH will be assigned to cluster 2 only. And the last part is extracting preference, where scoring of the cluster. That means if you take a word that is poor, and uh, we will calculate the sentiment value uh, by taking the score. That is, if it is positive, the score will be 1, and for negative the score will be -1. This is the proposed technique. This is the proposed technique. The working principle. First of all, step 1 is enter user information such as user ID, history of visit, and feedback rating. First of all, we have to create individual user profile. Then second, create individual user profile by collaborative filtering. The third step is merging individual profile into group profile. A group profile is represented as aggregate features of group members profile. Here we can see that there are a number of users and they have different informations like their IDs, history, rating, age, and feedback. So, individual having similar or related profiles will be grouped together. For here, in group 1, user 1 and user 2 have assigned because both of them have a similar profile. The fourth step is after creating the group profile, we will have some information about the group. From that feedback and ratings, the sentiment analysis will be happening in this portion to extract preference of the group. The next okay the next step is creating similarity graph. Each sentence, step 6 is each sentence positive emotion receive a score of 1 while the negative one receive a score of -1. These are the process of the sentiment analysis that we will be giving. The next step is to find the similarity of group I with the other group using the KNN nearest neighbor algorithm. So basically, we will take a group and we will find the similarity of the other groups by using the nearest neighbor algorithm. The final step is to ultimately derive the top n recommendation from the neighborhood of group. For each group, we produce a recommendation set of n locations that the target group is mostly like to select. And at last, the recommendation set will be generated. The conclusion, a current recommendation system after customized recommendations to specific customers. For activities carried out by group of people, they are therefore ineffective. In this work, a group recommendation system using sentiment analysis has been presented. The sentiment analysis has been extracted for the users for a better recommendation. In future, the working of the programming part where the model will be implemented using Python. Because group recommendation system using sentiment analysis is very important and powerful system. So there is a huge scope of exploration in this particular field. This will be achieved by comparing the proposed model with previous real-time recommendation system. These are the few reference that I have gone through. The rest are in the report. Thank you, sir.
Sir, if you have queries, sir, please.
So, Sriya, you are thinking about sentiment analysis. It's
Yes,
fine.
sir.
So, based on user satisfaction, you are telling based on the user's thinkings. But whether you have considered any aspect that, as like the false negative, false positive things, that to ensure a hotel, they themselves are creating the posts as positive one. How you can check whether any methodology is there? Because all the posts regarding a particular hotel may be good, may be bad, but it may not be from the real user. So whether you are getting any sense of real user,
Uh,
a, a bottleneck in your system. So whether you got anything about this?
Sir, till now I have not seen these things, but whatever you are saying, sir, this is totally true. That the hotels or the location itself they give the
Yeah,
false
in your
information.
you can get from Amazon all we are purchasing about a particular product. I can ask my friends or creating other false accounts. We can give good about the product, but the product may not be good at all. So these
Yes.
false positives, these false reputations, that is a problem to this recommendation system regarding sentiment analysis at that, because sentiment we are taking from the texts only. Those
Yes.
texts are manipulated.
Yes,
Try
sir.
to consider there is no foolproof system. People are working on it. In our university itself, the faculties are working on it, but we are not getting any good profile or good system that can check it. So let's think. You can also think. You can start to think.
Yes, sir. I will definitely keep that in mind.
Sure.
Okay.
Otherwise,
Uh,
it's okay. Thank you.
Thank you.
Yeah.
so, thank you, sir, for being
Thank you.
with us, for your time, sir.
Yeah. Thank
Okay.
you.
Thank
Thank
you,
you,
sir.
sir.